Hey everybody, this is Ryan DeGregorio, one of Wyoming Stargazing's program leaders. Thanks for joining me and welcome to Mind Bending Astronomy. In every episode, we'll share with you, a mind-bending fact about astronomy. Last time we looked at the size and scale of the universe and put our place in the cosmos into perspective. Today, we're going to talk about how the universe became so large and why is it continuing to get even larger. Astronomers have observed that the universe is growing. Specifically, what's happening is that the space between galaxies is increasing. A good way to imagine this is to picture a balloon with polka dots printed on it. As you blow air into the balloon, the polka dots get farther apart from one another, and the dots would represent the galaxies. And the air would represent something called dark energy. Dark energy is the most mysterious entity. No one knows its identity. It's called dark energy because something has to be driving this expansion, and astronomers are really in the dark when it comes to describing it. Dark energy makes up about 3/4 of everything that exists in the universe. Not only is the universe expanding, but the rate at which it grows is not constant. The universe is undergoing accelerated expansion. The velocities at which galaxies are moving farther apart is continuously increasing over time. It would be like blowing more air into the balloon with each passing second, so the diameter of the balloon grows exponentially. Well, what's going to happen to the universe? Will it rip apart like the membrane of a balloon with too much air? Will the acceleration ever slow down? These questions are at the heart of cosmology. To figure out what lies ahead in the future, astronomers have developed a model that involves the critical density and something called a density parameter. The critical density is just like ordinary density, mass per volume, and it gives the value at which the universe becomes stable and no longer expands. The density parameter is the ratio of the average density of matter energy in the universe right now to the critical density, and it's represented with the Greek letter omega. If omega is greater than 1, the universe will collapse back in on itself. If omega equals 1, the universe will continue to expand, but the acceleration will slow down until there is no more growth. And if omega is less than 0, then this accelerated expansion keeps on happening. The acceleration picks up, and there will be nothing else left to interact with one another once the last stars die. If omega is equal to 0, then we're talking about a constant universe, but that's not what the data show. Next week, we'll be looking at dark matter, something just as puzzling that makes up another 20% of our universe. It's totally unrelated to dark energy as far as we know. Nobody has come close as to what it could be yet.